Okay.
Hello, okay. Hello, everyone. Here is Qianzhen Rao from Shenzhen University in China. Today, I will report a joint work with Mr. Weike Pan, Zhongmin, and Yang Liu, named Behavior-Aware Variational Autoencoder for multi-task multi-behavior recommendation, what we call Bvae in short. And as the name, MNR is a recommendation problem that need to deal with multiple behaviors feedback as input, generating different recommendation lists for different tasks as output. The point is use one joint training outperforms the multiple single models. And it has two main challenges. Cause the behaviors feedbacks often be heterogeneous and the tasks related differently. MMR has two main challenges. The first is the efficiency challenge. And as I mentioned in the problem defined, it should be outperformance the multiple single models. And the other one is the adaptability challenge. You should always learn something useful, whatever the relationship between the behaviors or the feedback's distribution. Some prior work, such as heterogeneous one-class collaborative fitting, handle the multiple input. As one of our most related work, VAE was also once extended to address the multi-problem, such as VAE double plus. It designed a target representation enhanced modules and a target representation refining modules. But we think it is a pity that to incorporate with the auxiliary without enhancing their recommendation performance together. That is why within the multitask learning ideologicals are necessary, especially in the network structure, such as MLOE, and the loss minimization, such as uncertainty weight loss. Based on the above, we designed the Bvae module. It is extending from VAE and have 4 unicorn parts that we are going to introduce next. The behavior semi-encoder, what we call base in short. The dual gate network, including the global feature fitting and the target feature fusion network, what we call GFF and TFF respectively, and the standard deviation weight loss, called SDWL. Here is the framework of our BVAE. We consider that the traditional VAE does not learn the representation directly, but learn the lantern representation's mean vector and the standard deviation vector respectively. So we consider that the mean vector of VAE contains the global interaction features, and while the standard deviation vector learn the most user behaviors habits. So here, the mean vector semi-encoder is shared, and the other modules are behavior aware. The lantern representation, the mean vector can be, and the lantern representation can be filtered and fusioned through the GFF and TFF respectively, while the standard deviation vector can be reused as the weight to behavior weight to weight loss. When there is only one kind of behaviors, BVAE degrades into VAE. Superficially, the input of the shared part of the base is a multi-hot vector of the union behaviors feedbacks, and its output is the vector that will be used as the mean mu of the lantern representation later. Accordingly, the input of the executing part of base is the multi-hot vector of different behaviors feedbacks. And its output is the vector that will be used as standard deviation theta of the lantern representation. The GFF module uses a simple softmax gate to get a behavior-aware mean vector without adding too much parameters. After that, resembling the mean vector through the corresponding standard deviation, we obtain the lantern representation. The TFF module is similar, but its purpose is to push different lantern representations. So its gate is established between any two lantern representations with respect to one user and its different behaviors. Okay. The behavior-aware decoder reconstructed those enhanced lantern representation to the probability distribution, which reflects how much one user likes to behaviors on an item, just like Bvae do. Finally, the loss. The loss of single behavior is basically follow the Bvae, contain the KL and the reconstruction part. The main innovation here is we reuse the standard deviation vector learned in the base module as a task-dependent uncertainties to realize the automatic parameter adjustment. Experiment from 4 experts: performance comparison, components ablations, hyperparameter sensitivity, and adaptability study verify the effectiveness of our design. To begin with the experimental settings, 2 datasets from real-world economics has been perceived as showing below in the experiments. Notice that we split the dataset by timeline in order to avoid using future data for any other related user to predict the target user current interaction. In addition, the Jingdong car training set is empty after proceeding. Therefore, only other 3 behaviors feedbacks are used in the experiment, except for the adaptability study. We show our results through these 4 commonly used evaluation metrics and choose NDCG-F5 as the selection standard. The related method mentioned above and some other classical work be chosen as baseline. We multiple training the OCCF or HOCCF method to get the different target output with different inputs, such as we distinguish the single and the union, or the target and or auxiliaries to obtain the result of different behaviors tasks. Sorry. The MTR methods will be discussing in the ablation study part, because they can be the replacement components for the models, replace our base module. The best parameters are selecting on the valuation set by RecSys method following the original papers. Here is the experiment results, and we blow the best result and underline the second best result. From the perspective of the single or multi-behaviors, Bvae with union input performance is worse than the single target input, while in the most case, the HOCCF methods outperforms the OCCF methods. And for the perspective of the MMR problems, our Bvae can outperform all the baseline in a joint training in these 7 behaviors on 2 datasets, addressing the both challenges described earlier. So we can say that starting the MMR problem is meaningful. For the more comprehensive analysis, welcome to read our papers. And then the ablation study shows that after moving base GFF and TFF modules or training the module structure with MLOE or CGC, most parameter indicators decrease. It may because the number of the F-spur and the share part only for 1 for each behaviors. But with the same parameter amount limit, our base module has the best comprehensivity performance. Similarly, it's clear to see that the SDWL modules, as a flake part of the pictures, our performance outperforms the manually turned behaviors individual lost in most cases. Not to mention that when the behavior types increase or the tasks increase, that our SDWL module is more convenient. This demonstrates the components' efficiency of our model. In the hyperparameter sensitivity study part, whether the number of the top K raising or the lantern dimensions grows bigger, our Bvae constantly outperforms the second stronger list baseline, VAE double plus. Even more than half the case, the gap between these two increased. Last but not the least, the results of the adaptability study shows that basically, the greater the number of behaviors take part in the trainings, the better the results. What's more, the addition of the empty size, such as Jingdong cart training set, does not cause a crash. This demonstrates the adaptability of our model. In conclusions, to address the MMR problem, we propose a novel recommendation model called Bvae and be proven in significant experiment. In the future, we consider to extending the modules in sequential recommendation to get the user dramatic performance or to extend it to the cross-domain recommendations. Thanks for the following support and all your listening, and I welcome any questions you may have. Okay.
Thank you for the presentation. Is there any question from the audience or from Slido as well? I don't see any question here on Slido. Yeah, I have one in the meanwhile. It's about the domain of application of the model, because you have evaluated your approach on 2 data sets for the e-commerce domain, right? Yes. Where you have this kind of behaviors. Do you think that the principles can be also applied to other and different domains where you have different behaviors of the users?
Yes.
What is the effort, I mean?
Yes, in our work experiments, we chose the economic data sets, and maybe you can use in the other scenarios, such as the video, the click, and the share or other tests. And in our experiment, in our future work, we try to extend it in the such as Amazon books or the movies or the others. It also works. So the point is, it's a multi-input, multi-output problem model. So we call it MMR in short, not only the multi-behaviors. So.
Thank you. Thank you. It's clear. Any other questions?
Yeah.
Nothing on Slido as well. So thank you so much for the presentation.